thing, we make what's called G-code, and G-code is what controls the machine. So we'll make a file that says, machine,
do this.
Turn the spindle on, go over here, do this, cut this.
And what this software does, which is quite handy, it visualizes what the machine does. So you have a preview of what the machine will be doing effectively.
So right now the software is installed so that it comes up like this. This is the interface without me changing anything. So
we're opening this DWG file, which we need to change. So I've drawn this for 2 stools, but we're going to make just one. So what we can delete is all of
the left
or the right here. And then just grab these and put them over there.
So one thing I just noticed is that there's clamps in the corners of the part, so we probably want to avoid these areas.
So the clamps on the machine hold the panel down. So you need to the machine. You must want to cut.
So we'll want to kind of measure the clamps and make sure we have an area kind of like this to avoid.
Obviously now what we're doing, we're producing a bit more waste because we're sort of placing the pieces more in the center, but it looks like we're... You also need to allow for sufficient space between the pieces because the router bit has 6mm diameter, so and you need to leave a little bit of material.
How much space do you reckon?
So this currently wouldn't work, and you need a minimum, well, twice the tool diameter plus some extra, I would say. I would go for 20 probably as a minimum.
So this will allow, like, if you imagine a stick of wood, if it's going to be, you know, say 15 mm by, is it 18 mm or is it 12 mm? I don't know what the wood. What's your wood dimension?
It's actually 17.2.
Okay, so 17.2 thickness by say 15. That'll be a strong stick for you. If the stick gets really long, you might want it thicker. Say if you're cutting really long pieces, you might want it a little thicker. But that would mean that the leftover piece of wood here isn't too thin, and it won't like break. Because if we put these 12 mm away, there's 6 and 6, so it'll come to 0, and then you'll have a cantilevered, like in this case, like a pointy piece of wood there, and it won't be strong.
It won't. Yeah, you need to consider basically that there's no, like other machines have vacuum tables. There's one more thing, sorry, that we need to consider. We don't have plywood. We have, I don't know what the English name is, carpentry wood. So it's got 2 veneers, and then it's got a timber core. So we've got a directional material. So the direction of the core, like this, is fine, but we need to rotate this around.
This one?
Yeah. Because otherwise it won't work as a seat. You want the core to span this way. You don't want the core to span this way.
Otherwise it collapses.
I never use that stuff.
Yeah, it might not collapse, but it would be.
You learn something new every day. I've never used that before. I've seen it before, but I've never used it. I didn't realize it was like this. It's a little bit like, is it CLT? It's like these. It's almost like the kind of
the CLT.
Not nice version.
This doesn't really matter. I mean this. So we're basically having the timber core this way. We want the timber push around this way, and for this panel, hey, actually you're right because someone will be sitting on this, so this needs to rotate too. Yeah.
I don't know if we're going to be able to fit a lot of other parts on this.
No, it's okay like that.
I think I'll just be a little conservative. All right, so so this is the parts, and this line is representing our stock, which is 1.2 meters.
Have we actually measured? Should I double check?
Yeah, maybe.
You keep them going, and I'll double check.
Two size is not good for the base material.
What's that?
For the base rectangle, Now the size is two sides. Both sides are 1.2 meter.
It's a square, yeah.
Yeah.
It appears to be a square, and I think the material that was purchased was a square. Normally, it's I think it's 1220 is this actual length, and only
Yeah.
there's by
Correct.
2440. That's like a standard sheet, and then they cut it.
Yeah.
But
yeah.
yeah, there's other dimensions. So,
Mm.
and sometimes the cutting indicates strange shapes. So, as long as we have we account for some amount of gap, we should be kind of okay. But if it were too wrong, it could actually displace the part too far, and then we might have a problem with it. This
Yeah.
part's being this estimate allowing these parts to get too close to one edge or the other. Okay, so we need to set up the machine. Should be load from the file. I guess not. Post. AXIZ. Let's see. All right. So program. So tools. So we're going to make a tool. We're gonna sort of make a new tool, and the tool we have is flat. So this is like a rounded end mill. That's a flat end mill. This is a tapered or filleted end mill. This is like a point or beveling tool, and then this is like a drill bit. So they're just different types. So this is just a flat end mill, and we'll call it 6mm and up. So
Where will
6
this be saved? This setting?
Can I borrow your caliper?
Yes. Go for it.
I should have brought calipers.
It's probably on my table.
So we have a new name, and so our tool holder, we can measure these. So to simulate accurately, I'm going to leave them as default, but I'm going to change some of these numbers. So the tool diameter is 6, and I think the shank and the tool are the same diameter. So the shank is the top of the tool that goes into the holder, and the bottom of the tool with the blade is the actual, what they call the tool diameter, so it's going to engage the material. So in this case, it's it's like a cylinder that has the tools cut into it, the tooling cut into it, the grooves, the flutes, and so these are the same. The tool length, let's say it is 50, and we're going to say the shoulder length is 25, and we're going to say the flute length is 25. So that would mean that the tool is 50 length, and the blades are on 25, and then there's a part of the tool with no blades, like the upper part here, that's also 25.
Do we need to measure the exact dimension from the existing tools, or we just estimate it?
In this case, I will estimate.
Okay.
In the future, you guys should have a better estimate.
Okay.
But they don't use this to. You use this to simulate whether you're engaging in the correct way, and as long as we have a tool that's significantly more than 18mm, we'll be fine because we're not using anything thicker than 18mm, and our tool bit length is longer, and what the machine only knows is the bottom of this tool. That's all it knows.
Yeah.
So the machine doesn't know all these things. We just use it for visualization. So if you say went into 30mm material, you'd see a red mark here in the simulation that says that you're going deeper than the blade is allowed to go.
Yeah.
And yeah, we have a sacrificial layer underneath. Yeah.
Yeah. So there's a tool number, an adjustment register, a cut com register. I don't know what these things are. An axial offset. Were they saying this is HSS?
So that's what we were saying yesterday. Is carbide harder than HSS?
Yeah, you want carbide actually. It's significantly harder
Than
so,
HSS?
Yeah.
Right.
HSS deflects,
Okay.
which can be a little scary.
Okay. Should we double check?
Yeah, I'll do the settings conservative anyway. and so
Should be
it
alright.
okay. Yeah.
Okay.
So we can just go through the
But
motions.
you're saving the settings in the tool that you're just creating, isn't it? Or is
Yeah,
that for this job now only that you're doing this?
We can save this. I have to go into settings and figure out where the file ends up going, but we can do that. So you load from file. So we can do that.
I take a picture once you've completed this, because I would not be able to do this.
So the speed we're going to go at is 2,000.
So this is 2,000 millimeters per minute.
So in 2 meters, it takes 1 minute.
It's fairly quick.
So imagine walking, 2 meters in 1 minute. It's not super fast,
No.
but the tool is cutting through material, so it's also not slow. So this is a
you're-
kind of medium.
If you're forcing the tool that it bends, then you're wrong.
Yes.
What is departure?
I don't know.
But you're setting it in 3,000.
These are the movements afterwards.
Okay.
After it's cutting.
Yeah.
So this is plunge, so go down. Approach is the ramp, and then the engage speed is the same as the cut normally, but we'll keep these all slower.
What populated these defaults? Nothing. They were just random, or
I don't know. Sometimes people will use an algorithm that gives you chip load and so forth. So if you there's a calculation for if a cutting tool is engaging in material. If say the bit is 6 millimeters and it's a circle and it has 2 flutes and it's going at a certain speed, then you can calculate how much material it's cutting away, and that's called the chip load. And so there's kind of algorithms that set all this up based on chip load and stuff like that. So you end up with funky numbers sometimes.
well, I mean,
I don't know why they start with these funky numbers. They're really good.
I would expect to take all of this, in the Zund that we were using in Munich, all of this stuff comes from the database. You enter your material,
Yeah.
and then it populates that for you.
Yeah.
And
yeah.
if you're overriding it, it says, "Hey, are you sure?"
Yeah, I have a tooth that's a crown that they carved in the dentist's office. And if you put in a tool, it compensates for the tool and does the tooling operation and all the tool pathing automatically. So all the dentist does is say the part shape they want and then put in a tool, and it does everything automatically. It costs $1 million. It knows when the bit breaks. If the bit breaks, the machine knows. And if you put in a new tool, it knows the shape of the new tool and redraws the tool path. It's amazing. Such an amazing machine. It's this big, like that big, and it carves teeth. Anyway,
Where does it come from?
you can edit this out of the video.
Japan or?
Sarek, it's a company called Sarek, I think, and they make carving machines for
Dentistry.
dentistry.
Okay, so we've set this up now.
Okay, so
Tool diameter 6, that's the most important thing.
Okay. So yeah, and then we have to add tooling operations. So this is our stock.
So stock is the panel that we were working with.
And then we're going to say our Z is not negative 300. Let's say negative 18.
And so Z or Z is from the surface of the stock, right? We're measuring of the surface of the stock.
Yes. That was my understanding. So you can see
And now
this
it's
is
created
at
a
0,
depth. Yeah.
and it's doing that. And this is tapered. Why would it be tapered?
It's only in the now it's gone.
Oh, that's the preview. Sorry. Okay, good. Why is it weird?
I think it's just a rendering.
Yeah.
So the panel is actually 20 mil bigger either side. So it's 1.22 roughly.
Yeah, that makes sense. That's the standard size. Okay, so we can.
Or would you not leave that as a tolerance? No.
it's a weird unknown actually. I think the gap around everything is a better indicator.
Yeah, it might be slightly different for the different, but anyway.
Yeah, if we wanted to get closer to the edge, I think it would be good.
I think all that we need to do is where to lay it out on the like where's the zero that we're starting from, and
Stock setup. Oh, that's one. Okay. So stock 0. Set up 0.
you've pushed it there already. Yeah.
So that's already good. So save. So 2 axis, 3 axis. Oh no. Oh, 2 axis, okay, facing profiling.
We're doing profiling. Hold on.
Okay, so we've done the work 0. This is the stock setup. And so next we're going to do what's called toolpathing. So we're going to plan out a toolpath. So there's 3 axes, which is the carve. So there's horizontal roughing and then parallel finishing. So there's 2 ways to make a surface if you want to make a carve a surface. Unrelated to what we're doing. So then these are different types of 2D carving. So we're going to do profiles. Yeah.
And you could obviously sort of make that 2.5D by specifying a depth. So we still have a path, and we can then still specify the depth of the.
In this case, 2D almost always means 2.5D, because RhinoCAM acts as a parametric software that takes a base set of geometries and augments them with tooling offsets and lead-ins and lead-outs and all this kind of information. So all the parameters are set on here. It's like a kind of parametric model laid on top of another model. Yeah. They're super fussy parametric. So we have our tool, only one tool. Part regions, this is fine. Feeds and speeds, so we have all that. Clearance plane, automatic. Transfer method, part C plus distance 666. We're going to make it more than 6, so 20. And that's just going to be top of stock plus 20 to give us a higher. Oh, part Z mat, like part mat Z plus distance. What's mat? Oh, the mat Z height, I see. And then part height, stock mat Z.
So part max Z is.
So we're going to.
Why do you go for 20 rather than 18?
This is the height above, so this is for clearance.
Right.
So rather than be 0 along a part, so you might actually skim the top, you give yourself a clearance and then you move at high speed.
Mm-hmm.
So I'm just choosing a comfortable distance.
Oh, so this is the clearance plane definition.
Yeah.
Right. Okay. So this is another thing that you need to do. So.
Yeah, it does it automatically, but the automatic one was 6, which seems
Excessive. So
no, 6 seems like not enough. 20 seems better.
Oh, okay.
This is 20 millimeters above. Instead of 6 millimeters above, which is like this close.
Right.
So if one of the parts, for instance, was being cut and lifted up 6
lifted
mm,
up.
the part might just get cut with the thing. So you normally go beyond the material thickness.
Right.
Sometimes 2 times material thickness.
Yeah.
Just in case it's doing this.
It's lifted
It's
up.
unlikely it's going to do that, but
No, but it's definitely. I mean,
Yeah.
I've seen it happening that it just jumps out.
now you're freaking out.
All that this does is sort of increases the machining time, isn't it?
It does increase machining time, so it is,
But it's not a problem for us. I mean,
for this one we can see. So location of geometry. Okay, so there's control geometry, so this is going to allow us to.
now we need to select the paths before we did yesterday.
Select the region.
So this is important because we're sort of we need to the red and the blue means either internal or external cut.
So these are all internal cuts. And so one thing that's important is that the order I select them in is the order that they'll be cut.
Alright.
And normally you want to cut the sort of smallest parts first and go to bigger parts.
Yes. Yeah.
But that's a really general rule, and it gets very specific when you're actually cutting things. So
Well, you don't want
it's a rule of thumb.
yeah. The piece gradually loses the contact with the panel, obviously.
So we'll do there's advanced. So this is called bridging in tabs. So we'll do rectangular tabs, which will be 3 mil.
But for this we don't need tabs, do we? Oh yes, we do. Yes, you're right. Yeah.
Oh, sorry.
Or do we?
This is internal. Don't need any tabs.
Yeah.
Sorry. No tabs for the internal cuts. That we just throw this material away.
We stop the machine, throw it away.
Yeah. Or they get shot out when it cuts. That's something that happens sometimes too. Entry, exit. So this is the entry and exit moves that it will make. So currently, since it's internal and some of these are circles, we're going to make radial moves. Because if we do straight lines and it's starting on a tangent, it'll cut into the material we don't want it to cut. So we'll be tangent, and we're not going to give any length like this as an exit. We're going to do a radius that's 6 and a ramp height that's 6, 6, and a radius that's 6, 5, and then a ramp height.
And you're doing this because they're circles? Would you do the same if they're squares? It wouldn't hurt. Like it wouldn't be a wrong setting for a square.
For internal, it doesn't matter that much.
And external, it depends on how much material you want to lose.
Yeah, external, there's a chance that you're going to bump into other parts if you make this too long.
generous.
So you just have to, play it by ear. But normally for external ones, you just do straight line.
And what about dipping down and moving straight? You're burning.
If you just go straight down and then start, you can imagine you're driving your car, and you have to like turn 90 degrees and go like this. You have to slow way down. And while you're doing that, you're spinning at 12,000 RPMs. So you have to slow way down. You're carving the wood that you've already carved, and then transitioning. And so that's why you ramp down like this, and you're engaging more and more material. So you're engaging a little bit of material. It's going to put some load on the tool, and then you move to the next position, and you engage more and more material, and then you go kind of at full speed. So you're kind of like you're accelerating.
You want to gently accelerate.
And move out of the way of not. So one of the worst things you can do with these tools is to go very slow and just make a drill hole with it. It will start a fire. That's one of the most dangerous things you can do with a CNC router. Just take a tool and just go vertically very slowly down into a piece of wood. And then because it will rub and create heat, and eventually you just start a fire. It's pretty easy. Start a fire. Especially cut multiple holes that it keeps absorbing heat and gets hotter and hotter and hotter. And eventually it's red hot, just starts burning the wood instantly. And it burns inside the plywood, which is terrifying. So you can't see the fire. Can happen. Anyways.
Have you seen it happening?
Yeah, I've seen it happen. It's terrifying. Okay, so this is cut levels. So this is basically the step downs. So this is the depths that we'll use. So it's the cut geometry is at the top. Yeah, is where it's 0. And then the total cut depth is going to be 18.1. I'm just going to say 18.1 a little bit. The holes aren't as critical to totally cut through as much, I think.
No, I mean we will be 1 millimeter into the sacrificial layer of this.
0.1 millimeter.
17.1, yeah.
Oh wait, what is it? 17.1?
I think it's 17.2. The material is 17.2.
So 17 point like 3. We'll just barely go in.
Give it a tenth more. You know, there's tolerance to the material, and what is annoying if you route and then there's a little bit of material remaining.
Okay. 2/10. Yeah. 2/10, like this. 17.4, 17.2.
I would probably go for 17.7.
Okay. Rough cut depth. Yeah, finished cut depth. Okay, and then so you basically divide this total depth by a number, and then get your kind of number of step downs, right? So depth first or level first. So let's do. We want to do 3 millimeters.
Yeah. Is that the intervals that were?
Or 6 millimeters, sorry.
Yes. Yeah.
Well, this is dividing 4, so it gets us this weird dimension. So we have these choices because of the.
It's dividing it into 4 goes, 4 runs, or.
Well, yeah, it's like one. Yeah, one
So,
pass.
but what we're
2,
doing,
3,
what we're doing now, we're roughing and we're having a finish cut.
Yeah.
Because yesterday we weren't having one. Because we were, but now we know that we
I don't
haven't.
think we need to finish. We'll just do 0 as the finish depth, and there's no finish.
Okay,
cuts.
so only rough cuts.
Yeah. I think that's okay.
We have an upward tool.
We can do a
For the-
final finish on the outer one.
Yeah. so
No,
makes-
we're doing tabs. I mean, we're doing tabs. It's fine. I wouldn't do it. Let's be safer and do 5.3. That's a little less than 6. So, yeah. So now I have the entry and exit. This is for our tabs, but we don't have them. Our cut parameters is okay. Use inside of closed curves. So this is going to go on the inside of all of our curves. We're not going to do step over.
What is
That's
step
okay.
over?
Step over would be if you had a circle and say it was a fine material, you wanted a nice surface, you would cut a bigger circle and you come in and cut sequentially smaller ones until you got to the final nice surface.
Wow. Okay.
So that's done when you say you're cutting acrylic or some finished material, or like an iPhone. They do it on iPhones. This is made by cutting a final pass, which barely takes off any material, and then it makes this like
Chamfer.
nicer finish. This one's been sandblasted, but right. They used to not be sandblasted.
Okay.
And in some versions they're shiny, I thought.
Almost falling down.
No, I misremember. Feeds and speeds, clearance, plane, advanced. So that's all.
Safe.
So then,
What are you doing now? Do you do like another folder for the auxiliary ones, or you select and
why is it generating?
maybe just save every now and then, or?
Regenerate.
Oh, okay, regenerate.
I don't know why.
So this is already the toolpath. Now. Is there a 3D? Yes. Good.
So this is the ramp. I think we have to change this to do it at every height.
Yep. Remember, that's what we
So-
found out.
Oh, I must not have exits. At any rate, so these are the different depths. And then we're doing these. This is going to go buzz, 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 and make these little holes. So there. And these are the red is the move, the high speed moves after you're done cutting. Yeah. And there's a little bit more. So then this is the control geometry. So I can all those parameters are in this list here that we did, that we're looking at. So there's the toolpath. So we want to look at the feeds and speeds, clearance.
Do you need to double click to show the dialog? Oh, okay.
Not that frames.
Yes.
So entry and exit would be
apply
applied
at
here.
each cut. So that's an important one not to forget.
So it'll do that for each one. Tangent, radial, no linear, and no start.
Yeah.
So now that generates these, so you can see it. This is start and exit for each one. So you see how it's like a parametric model? It's a little bit like Grasshopper or something like that, where you have a base something, like some input geometry, and it adds a layer of parametric data.
Oh, and that's basically the parametric model that you meant when you explained that.
Yeah. It's
Which
a
is
kind
sort of a machine representation.
It's a very boring parametric model in a certain way, because it just does offsets. You know, it's very easy command, but yeah, you can use Grasshopper to write yourself code to generate tool facets. It's a pretty simple algorithm, actually. So we've done it a few times. Yeah. So next.
How do you set up? Yeah, how do you do a next one then? For the external ones, setup.
Well, you just add here. So
Oh, there. Okay.
Just do profiling.
Profiling.
So now we'll just start doing it again. So then we want. So I'm going to remove all of these.
Sure, you're not removing what you've just got.
Probably not. Well, I can select on this one, and I can alter region, right? So that's still there. Say generate.
Yeah. So now you've
So now
generated
it's
another folder, basically.
So this is going to be the second one, and we can just change the control geometry.
Has it just
Remove all.
you've just duplicated it essentially.
Yeah.
Duplicate.
Those. Enter. And then generate. But this is going to cut on the insides of these, right?
So we need to change it.
So the parameters for cutting outside are different than inside. So the one thing would be we want to be on the outside of all parts. Cutting to the right side, which I normally cut to the left side.
Of the tool movement of the path.
No. Yeah. See where these paths are? They're on the left hand side. So that means it'll go clockwise.
Yep.
I think on the other one I might go and change it. You want to go clockwise. The bit spins this way, and you want it to do this.
It spins clockwise.
Yeah.
So you want to have the movement aligning with the. Yeah. Oh right, that makes sense.
Well, it's just normally how I do it. I don't know the physics behind how the tool works when it does this.
Well, but
it seems to make a nicer path.
Yeah, and it sort of
Gotta
makes
finish.
sense if you have the tool movement and the spin direction moving against each other, then you're just creating additional friction or.
So cut levels are the same, no difference there. Entry and exit, we can just change to linear, and everything else will be similar.
So that it's ramping now linear, is it?
Yeah.
Okay.
So it should be a linear ramp, so it should just look like this instead of
Yeah, little arc.
like that. And advanced cut parameters, we are going to make rectangular tabs, and our height will do 3. 3 number, 5.
Yeah, a bit
And
broader.
yeah.
Remember, so the material has an external veneer, which is about 2 mil. If you want some material to be left from the core, then you better
5.
4 should be okay.
I'm going to generate this. I'm not sure what these will be like, because sometimes length means the length that it is generated or the length of the actual wood. You don't know.
The length of the actual wood. You mean the width?
So
the length will be
so the length is how long the toolpath goes
Yeah.
up and then over and
Yeah,
down.
yeah,
and
yeah.
Sometimes it's the length. I think in MasterCam it's the line length. It's not actually the physical piece of wood. That's
Oh,
length.
okay. So then there will
I'm
be.
going to say 10,
So there will be less.
and then we
there?
can preview it and see if it works.
Right.
Yeah, so there would be less. So we'll see that here. See, there's our tab.
Oh, did it place these now automatically, or?
Yeah. there's one parameter that I didn't set that I need to set.
Based on what?
So 4.
You want 4 bridges per piece.
I think it evenly divides the length of the perimeter
Of
into
the-
4,
yeah.
and then you get it wherever the start is.
Okay.
Yeah. I don't know if you can
So-
custom place them.
Is that 1, 2, 3, 4? Yeah. Okay.
Yeah. So
Yeah.
you can set the distance of the number. That's it. It's the only option. So
But that should be okay.
we'll just pray that it works.
Well, and this is why you need to observe the machine while it's working. Like you
So
cannot.
that's 14 millimeters, like 15 millimeters. Is this?
So it will be the finished length what you've just typed in. If this is 14, 15, maybe? No? I don't know.
Let's see, is this? Which ones am I looking at? Let's make sure I'm looking at the right one. I'm looking at multiples. It's probably that one. Okay. I just want to measure one. Let's see. So it's not making this 10, so it is compensating.
Where do you see the dimension?
I'm just
Oh, this is-
measuring this,
so
so this
16.
is 16, so it's compensating. So then,
But didn't you
is
type in 10?
good? Yeah. 10 is the piece of wood
Yeah.
that it'll leave. So is 10 good? Or do we do less? Is it unnecessary?
You need a saw anyway. It's fine, I think.
Okay. Alright. So
next,
that's it.
next time I will bring a Leatherman for this exercise.
I should have brought me digital calipers. I really like having digital calipers.
Well, you can probably buy one here in Hong Kong.
Why is that? Why does my angle look crazy?
Is that not just a perspective? Just it's one is in
No.
and one is out,
Yeah, and
But-
it's
but all the ins are.
different. Oh, see, the length is different here. 6,
For
9,
approach and engage? No, for
5. Yeah, yeah. Engage and retract.
right. But you said it now. Oh, you want it to be equal.
Yeah.
Okay.
It should look like that. It's broken to me.
Hmm?
It looked broken. It's like wrong shape.
Okay.
And then so I can. Why are you weird? Why did that change? That's weird, isn't it?
Maybe because of the duplication. Like, will it have changed all these settings now?
It's gonna cut on the left, and then cut on the side. And then the cut levels. Why is this all reset? It's such a bummer to reset all this stuff. Okay, cut levels. That one. Full contact is 7.
Did we lose all the settings?
For this one, yeah. So we'll go down to 5. Something. Oh, we're cutting this to 7? We're 7.2.
7.7, yeah.
Yeah, so that's all the same. Finished up with 0. First entry, exit is radial, 3.
If you guys remember doing this, you will be the most important people in the school.
What was the video? Oh, how bad could it go? Just trying to set up.
I'm just wondering whether you might be now overwriting the other one if they're sort of dependent from each other. I don't know. Just double check that. No, it's okay. Is it okay?
Yeah. I think I just made a mistake somewhere and didn't hit save or
Okay.
some other thing.
So wait, yeah, that looks good.
So if I select both, it'll show them. So when you select them, they pop up.
Okay.
I
So
Yes.
are you generating them as a single G-code file or as two different ones?
One file.
One
Well,
file.
normally I do it one because you don't have to change tools, so you just have one G
You
code.
can. Yep.
Sometimes you do this if you have to change tools and you don't have a tool changer. So you run with one tool and then you stop the file and then you change the tool and run the second tool. You probably just keep everything in the tool, right? I want to do applied each level. Okay. So that's our entry and exits there, entry and exits there. We're going to do 4 for each of these. 4, yeah. Okay. And 4. Yeah, so your entry here doesn't really give you great tab positioning, but that's okay. Because they're coming in your corners here.
It's alright.
Okay. Let's close it for now. Okay, and then there's simulate here. So
Should we do an overall save or something like that, or? You could save it to the desktop as well as the. Well, we can make a copy
I'll
then.
just put it in your drive, right?
Yeah, yeah.
So play. So this is gonna cut. So if you do. Okay, how do I?
Wow, it's rendering the whole thing.
Yeah. So that allows you to see if you, for instance, cut through the material.
Which we're not because we've set it to 18, haven't we?
Yes.
One important thing is to test that we're actually cutting through the material because nothing is more annoying than not cutting through the material.
I guess. Yeah. Bits flying off and hitting you in the neck is more annoying. I have to go through this whole thing and regenerate. Step levels stop. So this is gonna do.
Oh yeah.
Let's see it going through. And there's preferences for this. We could go into that, but in general, just see what's going on with this. Weirdly, it's missing curves.
Oh, is the curve?
I think it's the resolution.
It's the rendering, yeah. Jesus Christ, you can do a lot of stuff with this. Looks a bit curvier now.
Yeah.
Well, sort of.
Is it not? Is this hard on the machine? You can see it's generating. Yeah, the hardest thing is to actually play it real time. This normally saves you time if we have really heavy files for us to generate. So we have files sometimes with like with one, and there's like a million lines of G code. So it's like order of magnitude more than normal files. And so when we did simulation, when we tried to preview, we'd preview a small portion, and then we wouldn't preview the movements of the machine. We would just, you can say go to the end instead of play.
And see the result.
Yeah, I don't use this software that much, but in RhinoCAM it's kind of similar. with a lot more options. Master, get the difference in Mastercam.
And is Mastercam, would you prefer Mastercam to this? Obviously you do, but
Yeah, it's better.
it's better. Easier or more complicated?
It's a better software, period. But it's not easier. It's not easier than this. This is easier for sure. So for students, this is fine. I think it's okay. But at a certain point, if you're more advanced, you get frustrated because there's so much.
Okay. Right.
All right.